What's up, guys? Miss Delito here. Let's learn how to solve systems of equations without actually graphing them. So we're going to go ahead and take a look at 4 different examples here. And what you'll notice is that in all of these systems of equations that I've given you, we have our equations are equal to the same thing. So in example 1, our system y equals 3x plus 5 and y equals negative 2x plus 20, both of our equations are equal to y. What this tells us is that whatever 3x plus 5 is equal to and negative 2x plus 20 is equal to, they're both equal to the same thing, which also means that 3x plus 5 has to be equal to negative 2x plus 20. So we can go ahead and we can set these equations equal to one another to show that they are, in fact, the same thing or have the same value. So now we have an equation like ones that we've looked at before. We can solve this linear equation. So I'm going to go ahead, I'm going to start by subtracting 5 from both sides of the equation. And I'm left with 3x is equal to negative 2x plus 15. So again, because our goal of solving these types of equations is to get our variable to one side and our constants to the other, I will add 2x to both sides of the equation now. And I'm left with 5x is equal to 15. And then I will divide both sides by 5 to get the value of x, which is 3. So x is equal to 3. Now that I know the value of x, I can use this to help me find the value of y. So I'm going to pick one of my equations, but it can work with either and should work with both. And I'm going to start with y is equal to 3x plus 5. And now since I know the value of x is 3, I'm going to substitute that in for x in the equation. So y is equal to 3 times 3 plus 5, or y is equal to 9 plus 5, which is 14. So now I know the value of y is equal to 14. And we can double check that this is true for our other equation. So y should be 14 here as well. Negative 2 times 3 is negative 6, plus 20 is in fact 14, so I know I'm good. Now that we've got our value for x and our value for y, we have our solution to our system, which we're going to write as an ordered pair. So in this case, our solution is 3, 14. And this solution should make both of these equations true, which we just proved. Let's take a look at another example. So in example number 2, again, we have a system of equations where both of them are equal to the same thing. They're both equal to y. So y is equal to 5 times the quantity of x minus 3, and y is equal to 2x minus 6. Since I know both of these equations are equal to the same thing, or equal to y, I know that 5 times the quantity of x minus 3 and 2x minus 6 also have to be equal to each other. So I'm going to start by setting those expressions equal to one another. And again, we have a linear equation that we've got practice in solving. So I'm going to go ahead and solve this. First, I'm going to simplify. So I have 5x minus 15 is equal to 2x minus 6. I'm going to start by subtracting 2x from both sides this time. And I'm left with 3x minus 15 is equal to negative 6. Then I'm going to go ahead and add 15 to both sides. And I'm left with 3x is equal to 9. I'll divide both sides by 3. And I'm left with x is equal to 3. So now I have the value of x. Now that I have the value of x, I can use this to help me find the value of y. So I'm going to pick the second equation this time. Y is equal to 2x minus 6. And since I know x is equal to 3, y is equal to 2 times 3 minus 6, or y is equal to 6 minus 6, which is 0. So now I know the value of y is equal to 0. And we can make sure this is true in this equation as well. So if x is 3, 3 minus 3 is 0, 5 times 0 is in fact 0. So we know that this is the correct solution for this system of equations. And again, I'm going to then write my solution as the ordered pair, 3, 0. So let's go ahead and take a look at two more examples. So in example number 3, we have y is equal to 3 times the quantity of 2x plus 1 minus 4x, and y is equal to 2x plus 3. So I'm going to go ahead again, because both of these equations are equal to y, I can set both of the expressions equal to each other. So 3 times the quantity of 2x plus 1 minus 4x is equal to 2x plus 3. And I'm going to start by simplifying here. So we have 6x plus 3 minus 4x is equal to 2x plus 3, or 2x plus 3 is equal to 2x plus 3. So when talking about solving linear equations, we know that when we end up with two sides of the equation that are exactly the same, that they have infinitely many solutions. And this is going to be the case here as well. And we can prove that by thinking about what the graph of these two equations would look like. So we know that when we go to simplify this first expression, we end up with y is equal to 2x plus 3. And that's the same equation as our second one. So both of these equations have the same slope and the same y-intercept. Therefore, they will be the exact same line, and they will have infinitely many points of intersection or infinitely many solutions. So let's take a look at example number 4. So we have y is equal to negative 7x minus 1 plus 3x, and y is equal to negative 4x plus 6. So again, because both equations are equal to y, I know that each expression is equal to each other. So we'll go ahead and say negative 7x minus 1 plus 3x is equal to negative 4x plus 6. I'll go ahead and simplify this to negative 4x minus 1 is equal to negative 4x plus 6. So now again, from solving linear equations, we do know that we will have no solutions in this situation, because we cannot add or subtract something different to the same quantity and get the same solution. So we have no possible solutions here, and we can prove that by looking at what the graph of this would look like. So if we take a look and we simplify this, we know this would become y is equal to negative 4x minus 1. And we can see that these two lines, for the equations for these lines, have the same slope, but they have different y-intercepts. So we know that these lines would be parallel. Therefore, they would have no intersection point or no solution to the systems of equation.